This video will explain how to collect your data and do all the calculations for the modeling natural selection activity that you've been reading about a little bit. You answered the pre-lab questions, so you should have knowledge of some of the information I'm about to share with you. We'll be looking at how to collect the data and record it in data tables 1, as well as 2 and 3. You might want to include some of this information on your own sheet of paper so you have a reference point. You can always go back and find it in this video if you'd like, but it's probably easier and quicker if you just have it on your own sheet of paper. So the first thing you'll need to do is collect some beans. We need 25 pink and 25 green. Again, the pink beads represent the dominant allele. The dominant allele is brown fur. The green ones represent the recessive allele, and that is white fur. So you'll need 25 of each. You will also need one single dye. You also need one bowl and one paper bag. We're going to be using those materials today. Once you have your materials, we can actually now start recording some of our data. All right, so we're looking at generation 1 in each of our 3 data tables, and that's right where we're starting. So we're looking at the dominant alleles and the recessive alleles. We now have the information necessary to calculate the allele frequency. Allele frequencies, what they determine again, allele frequencies, if you forgot, is how common an allele is in the population. So this will show us how to do data table number 3. Let's take a look. So data table 3, we have our dominant allele, which is B. That was our pink bean. And we have our recessive allele, little b, which was our green one. So that might be a nice note to have just so you don't forget. And the number. How many pink beads do I have? This one's easy. It's 25 because that's what we started with. 25. We also had 25 of the green. That's easy. That's what we started with. So we have to figure out what percentage of our total beans are pink and which are green. So to do that, we need to know the total beans. In order to find that, we have to add these and these together. How many do we got? So 25 and 25, that's easy, that's 50. We have 50 beans. This number right here is what we divide by. And this number will change in every generation. So we're going to divide by this number. Okay, what are we dividing by? Well, we have to divide how many we have by the total. So we have 25 dominant alleles, 25 dominant alleles, 25 dominant alleles, and we're going to divide that by the total number that we have, which is 50. And this gives us an answer of 0.50. You can plug that in your calculator if you want. You'll get it. And this right here, that is our frequency. And we can plug that number right into this box right here. So 0.50. Now to get our percent, what we have to do is we have to take the frequency, multiply it by 100. So percent, we have to multiply that by 100. And multiplying that by 100, feel free to put it in your calculator, but 0.5 times 100 gives us 50. So that will be 50%. And we now can go ahead and plug that in right here. Now considering that we have 25 of the green recessive alleles, the math is going to be the exact same. Certainly we will see this change as we proceed through this investigation. You will get different values as you move down. All right, so let's find out how to proceed from here. Okay, so we got our alleles. We have data table 3, our first generation filled in. Now how do we actually start proceeding with the lab from this point? Well, the first thing I'm going to do now is I'm going to take all my beans, plug them into this bag. There you go. They're in there. This bag and all the beans in it represents my gene pool. Again, the gene pool is all of the alleles in a population. Our population off the get-go is going to consist of 25 mice, and we know that because there's 50 beans, and each mouse has 2 alleles. So 50 divided by 2 gives us 25 mice. Now, how do we go about collecting our data from this point? Well, all right. We know that brown is dominant, and that was pink. So we're going to have these possible combinations give us brown fur. We can get homozygous dominant, and that will give us a brown furred mouse. But we can also have heterozygous and get a brown furred mouse. So homozygous dominant, that will be if you get 2 pink beans. So anytime I pull 2 pink beans out of the bag, I got a brown mouse. Heterozygous, that would be 1 pink and 1 green. White fur, there's only one way to get a white furred mouse because it is recessive. We need the homozygous recessive. So homozygous recessive, and green was our recessive allele, so we need 2 green beans. Okay, now let's start collecting our data. This does go kind of quick, but you want to give your bag a shake. And now let's just randomly pull out 2 beans. Let's see what we get. I got 1 green and 1 pink. That is a heterozygous individual. It is a mouse with brown fur. So to complete my data table, now I'm going to put a tally mark there because I got 1 brown fur mouse. And I also need to complete data table 2 at the same time. This was pink and green. Pink and green, that is a heterozygous individual. We're using the letter B's, heterozygous. There we go, tally mark. Okay, now I have to determine, does this mouse live or die? Again, if you had gone through the reading, you would know that in order for a brown mouse to die, I have to roll a number 1. That means that there is a predator present, and the predator is able to see the brown mouse, and the predator eats it, and then this will die. If I roll anything else, the predator does not see the brown mouse, and the mouse lives. All right, let's check this out. Let's give it a roll. I rolled a 5, not a 1. This mouse lived, so I'm going to take this mouse and I'm going to set these beans off to the side. All right, don't get them confused. You might want to put them way off to the side so they don't get mixed up with your other beans. Okay. Second mouse. Got to repeat. And again, for each mouse, I'm making a tally mark here and here on data tables 1 and 2. Next mouse, I'm going to pick up the pace now. I got 2 pinks. That's homozygous dominant. And it is a brown furred mouse. Let's see if the mouse lives or dies. Rolled a 5, it lives. Set it off to the side with the other beans because they lived. Heterozygous, brown, live or die, live, set it off to the side. Okay, let's get another one. Got a green, so that is a white furred mouse. Let's see if this lives or dies. Got a 1. So a 1 meant that the mouse lived. The odds are against the white mouse, but it lived. So we're going to put that with the other beans. Mark it. We got a white mouse. It was homozygous recessive. Let's do this again. Heterozygous. Live or die. Live. Send the survivor pile. Let's do this again. And I got 2 greens, which is white, live or die. This one died. So I got white fur, homozygous recessive. It died. So this is where it is a little bit different. Whenever you get a mouse that dies, you put it in the bowl. Any bean that goes in the bowl, you never touch again for the rest of the investigation. These beans are officially done. So you'll set those off to the side. And that's kind of why we want to keep the dead beans separate from the ones that survive. I'm going to move my camera here really quick. You can kind of see I'm keeping the ones that live off to the side. The ones that die I'm keeping completely separate so that I do not get confused later on. At this point, you kind of pick up on the gist. I'm going to pause this video, complete the collection of my data, so that I can show you how to do the genotypic and phenotypic ratios. All right, so now I have my data for the first one, and you do want to double check, make sure that you didn't miss anything. We should have 25 mice in this generation because we had 50 beans. So if you add these tallies all up, it should come to 25. Same with these ones down here, mine do. So I'm good, I'm going to proceed. You should probably check that. To start with the genotypic ratio, again, that looked like this. We need to calculate that or use these numbers to kind of get that. So how many homozygous dominant do we have? 6. How many heterozygous? 5, 10, 13. And how many homozygous recessive? 6. Your numbers are going to be different than mine, but that's how you get it. How many do you have? How many do you have? How many do you have? That's what you'll need to do for the remaining generations. For this one down here, phenotypic ratio, brown fur was dominant, white fur was recessive. So how many brown furred mice we have? 5, 10, 15, 19. And how many white mice do we have? 6. All right, there we go.
Hey, Matt.
All right, so now let's take a look at my death pool. There's the beans I had in my death pool. Looks like I had 1, 2, 3, 4, 5 white mice die. So their beans are removed. I will not touch these again. These are the alleles or beans from the mice that lived. I need to figure out how many pink ones there are, how many green ones there are, and I need to record those for my generation 2 in my allele frequency. So I'm going to pause this video again. I'm going to count those up really quick so I can plug this in and show you this calculation one more time. All right, so I found out that after counting up the beans from the mice that lived, I had 25 pink still and 15 green. So I now can record those in my allele frequency for generation 2, 25 pink dominant allele, 15 green, 15 recessive allele. Now these are not the same, so these frequencies, they will change a little bit. So let's check out again how to do that math. First off, I need to know how many total beans I have now. I don't have 50 anymore, so I have to add 25 plus 15. If I add those two numbers together, 25 plus 15, I get 40. So that will be the number I'm dividing by now. All right, so I still have 25 here, so 25 divided by 40, 25 divided by 40. That gives me 0.625. So this number right here, that is my frequency. And in order to get this to a percent, I have to take this number, multiply it by 100, and I know that 0.625 times 100 will equal 62.5%. So now I can record this and this into my data table, 62.5% and 0.625. Again, your numbers are going to be different than mine, I'm sure, for most of these. Now I can do my recessive, 15. So 15 divided by 40, and that equals 0.375, which again, that is my frequency. Multiplying that by 100 gives me my percent of 37.5, and I can record those numbers for my frequency here. 0.375 and 37.5. Oh, I had those backwards. This one should go here, and this one should go here. Yeah, I just put them in the wrong spots, but I had my percents right. 37.5% and 0.375 would be my frequency. So that's how I calculate the allele frequency, data table 3. That's how I get my information for data tables 1 and 2. And at this point, you should have all the